In this video, we'll go over row echelon form, and then we'll also go over the row operations that you can perform to get your system of equation into row echelon form. And so row echelon form is abbreviated as REF. You can see that on your calculator. And I'll show you that next lesson, actually. And then these are your forms for row echelon form if you have two systems of equation and two variables, or if you have three systems of equation with three variables. I'm going to explain the three equations because it makes a little bit more sense, and then we'll come back over here to the two. So what you're looking for when you're looking for row echelon form, so first off, we have these zeros, we have these ones, and then the A, B, C, D, E, F, and then just the A, B, C over here. Those are numbers. And what you're looking for when you have row echelon form is that you have a diagonal of ones, and below that diagonal of ones, you have a triangle of zeros, which is essentially what's happening over here, just on a much, much smaller scale. You have your diagonal of ones, and then here's my little baby triangle of a zero. And so what's below that diagonal of ones are zeros, and what is above those diagonal of ones are all numbers. If we look at the example we went over here, this one here is almost in row echelon form. Okay. What is different between this and this to make this row echelon form? Okay. You don't need to write this on yours, but just to make a point, we do have our triangle of zeros here, but what I am missing is my diagonal of ones. If this -3 was a 1, then this would be row echelon form, where I would have my diagonal of ones, zeros below it, and then numbers all over here above it. Luckily for this class, we will never have to actually use these row operations to get this into row echelon form, but the standards do want you to be able to understand and use your row operations. And so these are the three row operations that you can do with any matrix, specifically an augmented form, but really any of them. The first thing you can do is you can interchange any two rows. And in my math lab, it's going to tell you just to perform the indicated matrix row operation and write the new matrix. So this right here is your notation to let you know you're interchanging any two rows. It's telling you you want row 1 and row 2 to interchange places. So I'm going to take my row 2 and write it as row 1. So this becomes 1, -5, 3. And now row 1 is going to become your new row 2. So 2, 4/5, and -7. So when you see that arrow going back and forth, interchange them. The second thing you can do is replace a row by a non-zero multiple of that row. So this is telling you 1/5 of R1. So you're multiplying your row 1 by 1/5, and that becomes your new row 1. Doing 1/5 times row 1 is the exact same thing as taking your row 1 and dividing by 5. So take row 1 and divide everything by 5. So 5 divided by 5 is 1. -10 divided by 5 is -2. 5 divided by 5 is 1. and negative 20 divided by 5 is negative 4. I don't have any other instructions on what to do to row 2 and row 3, so those just carry over. So row 2 stays as 2, negative 5, negative 6, negative 2, and row 3 stays as negative 4, 1, 4, and 6. You can see that both of these, if I was actually trying to get these into row echelon form, the first thing I need to do is get these ones in their correct spot. And that's what we have done for both of these. Now, again, luckily we don't have to do any of these by hand, but that's what we used to have to do, is to start here and to put it into this form. Or even worse, start here and put it into this form. And we would be using these row operations in order to do that. Now, on example 3, we already have that 1 in their correct spot, so we're going to be moving towards those other 0s and 1s. The third row operation is to replace a row by the sum of that row and a constant non-zero multiple of some other row. Okay, so here's what your notation is going to look like. We've got negative 2r1 plus r2. So what they are saying there is take your row 1, multiply it by negative 2, and then add that to row 2, and that becomes your new row 2. So negative 2 times my row 1, and then add it to row 2. So negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 1 plus 2. Do that for all of those numbers. So negative 2 times negative 3 is positive 6, plus negative 5 is 1. Negative 2 times 2 is negative 4. Negative 4 plus 3 is negative 1. And then negative 2 times negative 6 is positive 12. Plus a negative 4 is 8. Do it again, but now to row 3. So now we're doing 3 times row 1 and adding it to row 3, and that becomes our new row 3. So 3 times 1 is 3, plus negative 3 is 0. 3 times negative 3 is negative 9, plus a negative 6 is negative 15. 3 times 2 is 6, plus 4 is 10. 3 times negative 6 is negative 18, plus 6 is negative 12. I am multiplying row 1 by either negative 2 or 3, and I'm adding that to row 2 or 3, and that becomes the new row 2 and 3. I have no instructions on what to do with row 1, so my row 1 stays the same and carries over. And now you can see we have started on that diagonal of 1s, and I have started on that triangle of 0s. I only did one example of each of these, so rewind this and watch it again if you did not understand what this notation is stating, and then how to put those operations in place.